Hi there everyone. So I'm going to give you the notes on polygons. And the Polygon Notes, there's not a lot of math involved. It's more vocabulary and just knowing what to look for. But the definition of a polygon is a closed figure made of segments. We've already talked about what segments are. We know that they are just pieces of a line that have two endpoints. So if I look at all of the figures down here at the bottom, there are 10 of them, but not all of them are polygons. This one here in the middle of the top row is not a polygon because it's not made completely of segments. I can see these curves here on the corners are not segments. So anything with curved pieces to it is not a polygon. So that's not a polygon. A circle is not a polygon. And this is a quarter of a circle. That's not a polygon either. So anything that have curves in it is not a polygon. The only other one in this group that's not a polygon is this one over here. Okay? It's two polygons together. If I was just looking at this piece, that triangle, that would be a polygon. And this piece, that triangle, is a polygon. But together, it's not considered a closed figure because the two sides cross here at this point. So that's also not a polygon. Everything else here is a polygon, even if they look a little unusual. This here, I usually call that the factory, but it's still a polygon. It's all segments, it's all closed, meaning that all segments come together, so that would still be a polygon. The next definition to talk about is a vertex, and a vertex is just the point where sides of a polygon meet. So here in the triangle it has 3 vertices. 1, 2, 3. This rectangle here has 4. The pentagon has 5. And this one, 1, 2, 3, 4, 5, 6, 7, has 7. So vertices are just where they meet, and vertices is just the plural of vertex. Now, convex and concave. These are usually two vocabulary words that students mix up a lot, but convex are the ones that you're used to. All of these figures up here, all 5 of those, they're all convex. The unusual ones down here at the bottom, those are concave, but that's of course not the definition. The definition is if you were to connect any 2 vertices with a segment, that segment lies inside the figure. Okay, so I'm connecting any 2 vertices I want. So in the rectangle, if I'm connecting this one to this one, it stays inside. It doesn't go outside the figure at all. If I'm going to connect this one to this one, it stays inside the figure. If I want to connect this one to this one, it stays inside the figure. Any 2 I pick is going to stay inside the figure, and that goes for all of these up here. All of these are going to stay inside. Here I can draw a ton of different ones. They're all going to stay on the inside. All of those. Nothing is going outside. I'm being a little sloppy, so they're going outside. But really, none of them are going to go outside the figure. All of these, they're all going to lie inside the figure, and you can draw a ton of them here to see, but nothing's going to go on the outside. However, with concave, now at least one. So you only need one of the segments connecting two vertices goes outside of the figure. So you only need one, at least one. If I look at the star, there's a bunch that I could draw that would stay inside. All of these are staying inside. However, as soon as I find one, like this blue one, that goes on the outside, then it's concave. So on the arrow, I could connect these two, goes on the outside. I could connect these two in the X, and that's on the outside. And in the factory, I could connect these two. You only need one. As soon as you have one that goes outside the figure, then it's concave. Okay? And I know those two words are really similar, so it's always hard for students to remember which one is which. But convex is what you're used to. All of the segments are on the inside. And concave are usually the unusual ones, where you have at least one line on the outside. Now when it comes to naming polygons, you probably know some of these already, but polygons are always named by how many sides they have. 3 sides, of course, is a triangle. And 4 sides, we know a lot of different 4-sided figures. Rectangles, squares, trapezoids, parallelograms, they all have 4 sides. But to name them all in one big group, anything that has 4 sides, we can call a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. For some reason, we don't deal with 11 sides. I'm not sure why it goes right from 10 to 12. But 12 sides is a dodecagon. And then anything else that's not listed here. So 11, 13, 14, 15, 16, 50 sides, 100 sides, they don't all get special names. N could represent any number that's not up here. And you would just say it's an n-gon. So let's say you have a figure that has 20 sides, it would be called a 20-gon. If you would have a figure that has 50 sides, it's a 50-gon. They don't all get special names. Okay, the last vocabulary words here are equilateral, equiangular, and regular. And you can see from the first two, the equa at the beginning, so we know something's going to be equal. The first one, equilateral, this just means that all the sides are equal. And I put an example here of a quadrilateral, 4-sided figure where all 4 sides are the same. Okay, so anything that have all the sides are equal, we call equilateral. Equiangular, then, would be that all the angles are congruent. Or equal. Congruent, equal, those two words mean the same thing. Okay, so here I put another quadrilateral, only this time it has all 4 angles, 90 degrees, so that means all 4 angles are equal. And finally, regular means that both, so all sides and all angles are equal. So here I have another quadrilateral, only this time I have all 4 angles and all 4 sides. Everything's the same. So equilateral, equiangular, and regular. Now, not everything is going to be one of these three. Of course, there's a lot of shapes that will be nothing. All right, but just remember, same sides, if they're all equal, that's equilateral. All the angles is equiangular, and then if everything's equal, then that's regular. So let's go through a few examples now. So here I have a shape, okay? First of all, is it a polygon? Yes, it is. There's no curves happening there, and it's closed, meaning that all the segments come together. Is it convex or concave? The answer here is concave, because here's a vertice right here, and if I connect it to this vertice down here, that segment is outside of the figure, so it is concave. What's the name of this polygon? Well, I'm going to name it by how many sides it has. So 1, 2, 3, 4, 5, 6 sides makes it a hexagon. How many vertices does it have? That means how many corners. So 1, 2, 3, 4, 5. It's also 6. And then we have to answer the bottom question. Well, none of the sides are equal, so it's not equilateral. None of the angles are equal, so it's not equiangular. If none of the sides or none of the angles are the same, then it can't be regular, so this is none. Okay, it's not equilateral, equiangular, or regular. Our next example here, okay, is it a polygon? Yes, it is. Is it convex or concave? This one's convex. I could connect any set of vertices I want. These are all going to be on the inside of the figure. Nothing is going to be on the outside. Okay, we're going to name it by the number of sides. 1, 2, 3, 4, 5, 6. So we have another hexagon. And you can see that this hexagon and the one before it are very different, but it's all based on the number of sides. How many vertices does it have? 1, 2, 3, 4, 5, 6. And finally, the last question here. Equilateral means all the sides are the same. And I can see that, yes, these markings here tell me that every single side is equal, so it is equilateral. Is it equiangular? No. I can see I have 4 that are equal to 120, but 2 are only equal to 60. So no, it's not equiangular. So it can't be regular, so it's just equilateral. And finally, our last one. So, is this a polygon? Yes. No curves, and it's closed. It's convex, because again, all of the pairs of vertices, if I would connect them, that would all be on the inside. The name of the polygon, 1, 2, 3, 4, 5, 6, 7. So that's a heptagon. How many vertices? So count the corners. 1, 2, 3, 4, 5, 6, 7. And now for the last question. Equilateral? Yes, all the sides are the same. Equiangular? Yes, all of the angles are the same. So if it's both equilateral and equiangular, then we know that it's regular. So I would call this a regular polygon. Okay? So again, this section is a lot of vocabulary. So make sure you write down the definitions and you understand what they all mean. There's a lot of practice in the crate, and also IXL has really good practice for you before you take the test. So just make sure you know all the vocabulary before you complete the study guide. Okay, thanks for listening.